Right, let's do question 2.4. Given the quadratic pattern, between which two consecutive terms of the quadratic pattern will the first difference be 453? So in question 2.2, we managed to find that Tn is equal to 3n squared minus 60n plus 301. Between which two consecutive terms of the quadratic pattern will the first difference be 453? So the two consecutive terms means that we have Tn and also Tn plus 1. You see that these are the terms that follow each other. If this is n is 5, then here is going to be 5 plus 1, which is T6. If n is 7 here, then here is going to be 7 plus 1, which is T8. You see that? So these are the terms that follow each other. So we have our Tn here. Let's find our Tn plus 1. So Tn plus 1. Where there's n, we put n plus 1. So it's going to be 3. And then n plus 1 squared minus 60 n plus 1, then plus 301. Right, we can simplify this. Tn plus 1 is equal to 3. Then expand this. N plus 1 squared. Remember how we expand the square binomial? We say n squared. This becomes n squared. We take this sign here plus. And then 2 times n times 1 is 2n. And then the last one is always positive. And then we square 1, which is 1. Right, we can do it the long way like this using a FOIL method. N plus 1 times n plus 1. N times n squared. N times 1, that's n. 1 times n, that's n. 1 times 1, that's 1. Then you get n squared plus 2n plus 1, which is this. And then let's distribute negative 60. So it's going to be negative 60n minus 60 plus 301. And then this is equal to 3n squared plus 6n plus 3 minus 60n minus 60 plus 301. If we subtract, if we say Tn plus 1 minus Tn, we must get 453. So this is our Tn plus 1, which is 3n squared plus 6n plus 3 minus 60n minus 60 plus 301 minus Tn. Our Tn is this. So Tn minus 3n squared minus 60n plus 301 is equal to 453. Right, let's remove this bracket. It becomes 3n squared plus 60n plus 3 minus 60n minus 60 plus 301. Then we're distributing the negative here. It's going to be negative 3n squared plus 60n, then minus 301 is equal to 453. 3n squared minus 3n squared is 0. Negative 60n plus 60n is 0. Positive 301 minus 301 is 0. So what you remain with, we have this and this, which is what? Which is 6n minus 57 is equal to 453. Then we add 57 on both sides of the equation. We'll get that 6n is equal to 510. Then divide by 6 on both sides of the equation. N is equal to 85. So therefore, between which two consecutive terms of the quadratic pattern will the first difference be 453? So it's between T85, because n is 85, and T85 plus 1, which is T86. Another method we can use, we can say this is 244, 193, 148, 109. Right, we find the first differences, negative 51, then negative 45, then negative 39. Negative 45 minus negative 51, we get 6. Negative 39 minus negative 45, we get 6. So if you check, the first differences, they form what? They form a linear sequence. First difference is 453. We have to find the term number for 453 as the first difference here. It will be term number what as the first difference. So we use the linear sequence formula. Tn is equal to an plus b. Then the a is the common difference, which is 6. So it's going to be Tn is equal to 6n plus b. Then we can use our negative 51 as our first term. Negative 51 is equal to 6 times 1 plus b. And then we subtract 6 on both sides of the equation. So it becomes b is equal to negative 57. Okay, b is equal to negative 57. So now therefore Tn is equal to 6n minus 57. 453 will be term number what? 453 is equal to 6n minus 57. Then we add 57 on both sides of the equation. 510 is equal to 6n. Then divide by 6 on both sides of the equation, n is equal to 85. So it means 453 is term number 85. Then term number 85 means now this 453 will be between T85 and T86. If you can check here, the first term for the linear sequence is between T1 and T2. The second term for the linear sequence is between T2 and T3. The third term for the linear sequence is between T3 and T4. So the 85th term of the linear sequence is going to be between T85 and T86. You see that?